You know that I love Project Drawdown, sorry, and I love their reports. They're always very useful, especially for pedagogy, for teaching these climate solutions. This is a report that's already a couple of years old, but the information is really awesome, very useful, and is not going to, expire in terms of, timestamps. So this is a drawdown primer, farming our way out of the climate crisis. I'm not a big fan of this word crisis, as I've said on many occasions, because everybody is living a normal life, even the climate scientists. So we keep saying there's a crisis, but we keep living a normal life. Changing our land use, agricultural practices, and food systems offer numerous opportunities to reduce greenhouse gas emissions, sequester atmospheric carbon, and help address climate change. So we talk about agriculture now producing about 25% of the overall greenhouse gas emissions, but it doesn't have to be that way. So this is about how we can produce food, which is of course needed, and more of it will be needed as population will grow for some more time. I mean, there is evidence that we have enough production, but distribution and access are issues and so on. Nonetheless, as usual, I'll be very brief. I'll just read the captions, kind of the summary part of each chapter with some figures to add some points. A very nice report, very detailed, lots of excellent references. So you want to go back and read the report if you are interested in this topic. Okay. First one, introduction. When we think of climate change and greenhouse gas emissions, we usually envision power plants, factories, cars, and smokestacks, not farms and ranches. But it turns out that agriculture and land use, as well as the larger global food system, are among the biggest contributors to climate change, and as a result, changing these systems can be an important source of climate solutions. But how can this be? Isn't climate change caused by burning fossil fuels that release carbon dioxide into the atmosphere? There is more to it than that many sectors like farming can produce greenhouse gases in ways that we have to understand so that we know how to reduce those emissions. So here is a nice figure showing the greenhouse gas mixes of carbon dioxide, methane, N2O, and flue gases or fluorinated gases. Here we show the different greenhouse gas emissions that are contributing to global warming. Each gas was weighted by their global warming potential to show an equivalent amount of warming each gas will cause in the coming century. I've discussed the global warming potential elsewhere, but CO2 is taken as baseline of 1, and depending on how much more powerful a greenhouse gas is that is not CO2, like methane and N2O, we call that the global warming potential. You have some details. Is it done by weight or by volume, and so on and so forth. Okay, so 62% from burning fossil fuels is CO2. Then you have flue gases, N2O from agriculture and industry at 6%, methane from agriculture and industry, so rice paddies, and of course livestock, which is not separately counted here, but CO2 from deforestation and land use is another 11%. So you have almost 75% of CO2 emissions, and you have CO2 from cement, industrial and chemical sources at 3%, and these are really stubborn in terms of our ability to reduce them. Okay, so primary sources of greenhouse gas emissions, then electricity production is a lot of it, but you can see food, agriculture, and land use is almost equal to that, but it depends on how you count these things. Okay, industry is 21%, transportation is 14%, buildings on-site 6%, and other. So these are greenhouse gas emissions that come from a variety of sectors, including electricity, food, agriculture, and land use. So forest, food, agriculture, and land use called FALU. Industry, transportation, buildings, and others also contribute. It's important to note that food, agriculture, and land use is nearly tied with electricity as a leading contributor to climate change. But if you take all the production, actually in some places energy production would show up as 75% of all the emissions. So now these are perennial root systems that can really put away carbon and keep it there for a long time, and sequester it into the soil if we don't perturb it especially. And sometimes warming also causes microbial activity that respires the soil carbon. But imagine that electricity generation and land use and agriculture are basically equal in terms of their global impact on climate change, yet addressing the greenhouse gas emissions from electricity generation and other sectors usually gets far more attention. Right? So if you look at the rainbow diagram of emissions and sinks, here we are showing the primary emissions of greenhouse gases on the left here, as well as the current natural sinks of greenhouse gases that remove CO2 from the atmosphere. So today's sinks and today's sources. Agriculture is a key player in the emissions here and can enhance the size of the land-based sinks of the greenhouse gases. Okay, so just look at other at 10%, so other energy related emissions, buildings, transportation, industry, food and agriculture, and land use that we already. So we're looking at it different way here, but it's a nice diagram because it shows the sinks as well, and electricity production. So here is the atmosphere holding about 59% of the emissions, but the rest of it, 20%, goes into land sinks and about 17% into coastal and ocean sinks. Obviously you want to reduce the amount in the atmosphere because that's what affects the energy balance, greenhouse effect and warming, and you want to enhance land sinks and ocean coastal sinks, but also reduce the sources, right? Mitigate the sources. So reaching drawdown, what does it require? You have greenhouse gas concentrations that are increasing despite all the negotiations. We continue to not only increase but accelerate. So drawdown is defined as the moment when greenhouse gas concentrations stop climbing, reach the peak and start to steadily decline, thereby stopping future climate change. Business as usual would keep on increasing faster and faster the greenhouse gas emissions, but the moment of drawdown is gonna peak the emissions and then boom, we are gonna drop. And this is also debated as a whole as to when we should reach the peak and how fast we should be drawing down and so on, in the context of the global warming targets like 1.5 degrees C and 2 degrees C. So the second chapter here, climate impacts of food, agriculture and land use. Again, lots of good information in the chapter. I'm just going to take the most salient points, subjectively my choice, but you can go back and read the report. The world's food and agricultural systems are having a profound impact on planet Earth. The world's land cover is dominated by agriculture. Today it's about 35% of the world's ice-free land is used for croplands and pastures, and if you remember that almost 70% or more of the freshwater resources are used for irrigation, then you know you have issues. Today, about 35% of the world's ice-free land is used for croplands and pastures. Some estimates are even higher. No other force has shaped the Earth's surface as much as agriculture, and we started this 10,000 years ago. The continued expansion of agricultural land in the tropics is leading to deforestation, especially in the Amazon, West Africa, the Congo, and across Indonesia. By clearing land and habitats, agriculture is the single biggest driver of biodiversity loss worldwide. What is the breakdown of emissions from food, agriculture and land use? You have almost all of it from food, agriculture and land use, but 9% of land use is deforestation. Methane from animals and rice is at 6%. These numbers are for some particular period, so they are subject to change, but the main picture doesn't change in terms of who dominates and who contributes. 4% from nitrous oxide, which is generated by fertilizer and manure, and 5% other, which unfortunately also includes waste. which is unfortunate. Breakdown of methane and nitrous oxide emissions. So you have anthropogenic sources at 62%, enteric fermentation of ruminants, rice cultivation, manure management, burning savanna, land use change, and burning crop residues, which is a big pollution problem as well, even though here it's tiny bit, but locally, like in India, northwest India, it can be a significant source, especially in some seasons when you transition from the Kharif season of the monsoon, summer monsoon, to the Rabi season of the winter crops. What about N2O? 29% manure left on the pasture, 29% from the manure left on pasture, which is just releasing N2O. Manure applied to soils, manure management, synthetic fertilizers is a big chunk here as well at 23%, and you have all other anthropogenic sources, land use change, cultivation of organic soils, burning savanna, crop residues, and burning crop residues shows up here as well. Okay, so third chapter is on reducing greenhouse gas emissions from agriculture, which is where we are heading into drawdown. Because land use and agricultural practices are such big emitters of greenhouse gases, they need to be a big part of our solutions to climate change. The most important things we can do to reduce emissions from land use and agriculture include, I will come back and do this because I'm getting a phone call, as you can hear. Okay.